Wait before you're just gonna skip the intro. Let me introduce myself. Hi, hello guys. This is Medbits, your exam savior, and today we'll be discussing about Gait Cycle Part 2, biomechanics. And yeah, those who didn't watch Part 1, please go and watch that. Link in the description below. So, as you see a chart in front of you right now, saying gait analysis, and there are two parts, which is kinematics and kinetics. So right now we are discussing is the kinematics part so far. So kinetics is something that we'll be discussing in a different video as a different topic. So let's right now focus on kinematics. So in kinetics we'll be discussing more about GRF, ground reaction force, power, torque, so and on. And in here kinematics we'll be discussing about temporal and spatial. So there will be timing variables during gait, so the distance variables during gait, and there will be joint angles which is of upper and lower extremities. We'll be discussing about that. And then there is the descriptive components of gait, which is then coming to is determinants of gait, which is pelvic rotation, tilt, etc. And yeah, so now as said in kinematics, now one of the part is temporal and spatial, right? So now in temporal we'll be discussing more about stance time, single limb and double support time, swing time, stride and step time, cadence, speed. Then comes as in spatial is stride length, step length and width, degree of toe out. So these are the things that we'll be discussing more about. Now, before proceeding into the video, I know that you all are comfy sitting in your chair and listening to this video. Now, believe me, if you really want to learn this fast and to make it much more understanding, you have to do it practically. A topic like gait is something that you have to do practically to understand. So it will be really better if you're just standing up and doing it practically. Okay. So coming with the first one is stance time. So it is a amount of time that elapses during stance phase of one extremity in a gait cycle. Now consider yourself walking, and now you know the situation where one of your leg is only contacting the ground, right? And where the other leg is preparing for heel strike, right? It is going to contact the ground any moment. So the amount of time where your leg is there and where your other leg is going to contact the ground, right, where it's going to strike the ground, is at stance time. Okay, yeah. Now coming to the next one is single support time. It is the amount of time that elapses during the period when only one extremity is on the supporting surface in a gait cycle. Okay, so double support time, it is the amount of time spent with feet on the ground during one gait cycle. The percentage of time spent increased in elderly persons, right? We have seen our elderly parents, our grandfather or our grandmother walking slow with a low trajectory, with no like with increased amount of stance time, right? So in those with balance disorders, so the percentage of time spent decreases as the speed of walking increases. Okay. Stride length. It is a linear distance from the heel strike of one lower limb to the next heel strike of the same limb. As you can see, heel strike of one lower limb to the same limb, right? So you can see the distance. So this is the distance as we are talking. Step length. It is a linear distance from the heel strike of one lower limb to the heel strike of opposite limb. Heel strike of one lower limb to the heel strike of the opposite limb. Stride duration. It refers to the amount of time taken to accomplish one stride. Stride duration and gait cycle duration are synonymous. One stride for a normal adult lasts approximately 1 second. So yeah, that'll be it. Step duration. It refers to the amount of time spent during a single step. Measurement usually is expressed as second per step. Walking velocity. It is the rate of linear forward motion of the body, which can be measured in meters or centimeter per second, or meters per minute, or miles per hour. Walking velocity is equal to distance walked per time. As you can see, meters second, and here in the bracket, so we just gotta read that up. Okay, yep. Now let's go. Cadence. It is a number of steps taken by a person per unit of time. It is measured as the number of steps per second or per minute. Cadence is equal to number of steps per time. Speed of gait. It is referred to as slow, free, and fast. Free speed of gait refers to a person's normal walking speed. Slow and fast speeds of gait refers to speeds slower or faster than the person's normal comfortable walking speed. Okay, coming up with the next one, step width. Now it is the measure of linear distance between the midpoint of the heel of one foot and the same point of the other foot. Right now, as you can see, the step width. Right, okay. Now coming to next one is degree of toe out. Now if you're just standing just still right now, you'll be seeing that your feet will be angled like this, right? It will be a bit away. It just, let's say, a 20-degree deviation like that. Yeah, so yeah, degree of toe out. It represents the angle of foot formed by each foot's line of progression and line intersecting the center of the heel and the second toe. So the degree of toe out is 70 degree on an average. Okay, yeah, I was wrong on 20. Yep. Determinants of gait. The determinants represents adjustments made by the pelvis, hips, knees, and the ankles that help to keep movement of the body's COG, which is center of gravity, to a minimum by decreasing the vertical and lateral excursions of the body's center of mass. Energy expenditure would be less and gait is more efficient. So like these are the determinants now we'll be discussing, and let's just discuss about them. Right, I'll just pick one by one. Now pelvic rotation is the first one, then lateral pelvic tilt, knee and hip flexion in stance phase, then comes this knee ankle and foot interaction, knee mechanism, lateral displacement of body and center of gravity. Yep, that's what we're gonna say. Pelvis rotation, alternatively to right and to left in relation to the line of progression in transverse plane about the vertical axis. So you know that this is the transverse plane, right? Okay, good. Magnitude 4 degrees on either side of the central axis. Associated hip movement, internal and external rotation during stance phase. Okay, so yeah. Pelvic tilting. Now the word itself says what it does, right? It's a tilt. As you can see, there is an anterior tilt and there's a posterior tilt. Okay, so yeah, as you can see, an upward tilt, downward tilt, external rotation and internal rotation is also considered in that way. So now let's continue. The pelvis tilts downward on swing leg on the side which is opposite to that of weight bearing leg. Okay, so it's a continuation from here. Okay, along the frontal plane around the sagittal axis. Now magnitude is 5 degrees. Associated hip movement, hip adduction in stance phase and hip abduction in the swing phase. Hope that's clear. Knee flexion in the stance phase. At initial contact, the knee is almost 0 plus or minus 5 degrees. At loading response, the knee begins the first excursion of flexion after the heel strike, right? First excursion, as you can see, the flexion. So, which is is equal to 15 degree minus 20 degree. It has three functions, which is, as we know, shock absorption, minimize displacement of center of gravity, decrease energy expenditure. Now, early in the stance phase, at mid stance, the extension of knee reaches 5 degree in flexion. At terminal stance, the knee joint reaches 0 degree of extension to start the first excrusion of knee extension. At pre-swing, the knee joint flexes up to 10 degree flexion to start the second excrusion of knee flexion. Yep. Now coming to next one is foot and knee mechanism. So as you can see here in the image, each segments show each mechanism, right? So I'm just gonna explain them out. Okay, so early in stance phase, as you can see, the foot is dorsiflexed, knee is extended, right? Extremity is max length, so center of gravity reaches lowest point in a downward displacement. Late in the stance phase, now here foot is plantar flexed, knee is slightly flexed, right? It is slightly in flexion. Maintain COG, which is center of gravity, in its beginning of progression with minimum displacement. Lateral displacement of body and center of gravity. Center of gravity displaced laterally over the weight bearing extremity twice during the cycle of motion in the horizontal plane. The motion is produced by the horizontal shift of pelvis and relative adduction of hip. So the magnitude in here is 4.5 centimeter each stride. Okay. Congratulations guys, we have learned gait cycle, and I hope the topics on this video is very clear and sound for you. And yeah, good luck on your exams. Believe in yourself, hope for the best, pray to God, have faith, and yeah, everything will happen in good times. And yep, until then, see you on next video. So peace out.